when it comes to development is I like to keep things simple. Maybe everyone says that, everyone goes with KISS, but I actually like to keep things simple. And I started out, everyone starts in C++. I had a moment about 6 months in where I read somebody saying, you should just try C instead of C++. And it was like mind blowing. When you see, I could actually understand everything that was happening. I could understand everybody else's code. You couldn't screw anything up. And I was much more productive. That kind of speaks to how I approach development. C over C++. And F#, I find, as I put in the intro text, that it fits the right mix of simple and powerful. So you don't want to go down crazy things like Haskell we were just talking about earlier. Very academic language, incredibly powerful, but you just don't want to mess with that. It's chaos. It's crazy the amount of stuff you have to understand. Like, I know what a monad is, or a monoid, and it's had no effect on how I do my job. So it's just, we just need to keep it simple as we can. So I'm doing this from a very human point of view. I'm not going to be dipping into the academics or going deep into type theory or anything crazy like that. Just why would the average dev approaching this, what would they feel about it? All right, so the way I'm going to do it is it's all live code. Could be a bit dangerous. I'm just going to type things out. We're going to talk about them. I'm going to ramble. And if it gets a bit dry, check out some other examples. Right. So let's get my share on. Okay. Let's see that. All right, so I tend to use Rider for mod. It has pretty good support for F# these days. The common use though is the common tools are VS Code and a plugin called Ionide, which is very good also. Would highly recommend it, and it's free, so definitely go on with that. So here's the hook we're going to go with. Type providers. It's a feature of F# which is just, there's nothing close to it in C#, and it's cool. What is a type provider? It's something that gives you it generates at compile time a full and real type based on, well, all sorts of different things. There are a bunch of different kinds of type providers. So go on here, a JSON provider. I've got this file. I just literally just Googled for JSON example, found this. It's just some names, phone numbers, whatever. I give it to this JSON provider. I ask for the sample we have back. What we have in here is an array of users. As we can see here, we've got an array. Got to get the first one, array indexing, very similar to C#. And what is that doing? Fantastic. That is, and look at that, a real strong, proper static type for this in 2 lines of code. We got this going on here, and it will work out things of what they need to be. If I, well, that's a string number. If I were to remove one of these fields, it will just work that on the spot. Could be a string, it could not be a string. It's optional. We'll get into options a bit later if you're not familiar with them. I'm going to be addressing sort of functional idioms as well. So there'll be 0 expected knowledge of it, but like from a C# code's point of view. So just right off the bat, that I find pretty amazing. It can just crank your productivity up massively. I use these kind of things generally in little scripts. Just you get some JSON, you want to do something with it. Most people would use Python, I imagine, for this, but type providers make life just so easy here. So it does this at compile time. You can use a sample file. You can just throw the JSON directly in there if you want. We'll check out some other ways of doing that in a bit. So let's switch over to using VS Code, just because it works a little slightly better with scripts, which we'll just dip into a little bit. So an easy way to get into using F# would be just writing a little script here and there. You may have heard C# has CSX files these days for C# scripts. I don't know anybody who ever actually uses one because they're not super great. I haven't used them much myself. F# are quite a bit better. So we can see this first line here. we can reference a NuGet package right in here. This is literally just a file. I just made this demo.fsx. It's just a file. There's no project around it. There's nothing. And we can reference NuGet, and we can just throw in exactly what we had over here, and it would work. I think this is in the same folder. Might not put that in the same folder, but anyway. So we can reference Newtonsoft and anything we want from there for just quick and dirty little tasks. I never use shell scripting anymore. Like I used to get quite annoyed with bash syntax and how many thousand parentheses do we need for this one and square brackets and whatnot. And I switched to Python for a bit. Now it's all just F# because life is so easy. I might show you an example of one I have lying around a bit later. But for now, let's move on with some bits of the language, shall we? So, delete this. Well, so we start with a type there. So type. So we don't just have classes and enums and structs in F#. We can do a bit more with types. So the simplest thing we can define is an alias. So we can just say we have a type. Many equals there. We can just create a type alias for beans here. We could create a function. We can add beans together. All right. X plus y. It's just like an integer. So let's take a look at this. This is our function signature. It can be a bit confusing initially. What that means is this is a function, it takes an int, returns an int. But why does it look like this? Why does it look so confusing with the little arrows? So what that is because we have currying in functional languages, or a lot of functional languages. You may have heard of currying or partial application. They're very similar things, no point going into the difference. But what this really means is this function add, it is a function which takes an integer, one integer. We have two parameters here. It only takes one integer, and that returns us another function which takes one integer. And that returns us our final integer. So this allows us to do some pretty crazy things. I mean, you can do these things in F# with lambdas. You could just capture variables and things. But when it's built in, it's idiomatic. It's this simple. It's a really nice thing to do. So we can say, I could define another function called add5, which will take a y. And all we need to do is call add with a 5. So what this did, we gave it its first parameter, and it gave us a function expecting the second parameter. So this is kind of the heart of functional programming, is composition. You can just build things up. It doesn't seem super useful when you're talking about adding two things together, but imagine it's a repo we're talking about. So if we had a function called like save user, and we have dependency injection. Dependency injection in F# is really just functions, like everything is just functions. We could do this. So it takes a repo and it takes a user. I want to save it. We won't do anything with it. We'll just return unit. A unit, if you're not familiar, is what we use in place of voids. So a void is in most C-based languages. It doesn't really, it isn't something. It's not a type. It's not a. You can't have an instance of void or anything. It doesn't really fit in with all the other types. In functional programming, we tend to use units. It's a real type. There's only one instance of it, and that is this. So it just means it kind of flows better with everything else you're doing. Every function will return something, even if it's just unit. Just to explain little parentheses there. So if we had users, we might call that with like a DB repo somewhere and a user we have. So we don't have those lying around right now, but so that might be an example to do it. But we don't want to have to care about this DB repo. What if we just want to pass this in and make it usable as it is? We can create this super simply as this. Now we have a function which will save our user directly to the DB. But wherever you expose this function, they don't need to know anything about the database. They don't need to know anything about repos, about how this is being handled. It's just going, you were just saving a user as far as you're concerned. It's hiding the details in just, again, a much simpler way. This is just a couple of lines of code here in how we're doing this. I'd like to just show you a screenshot of, where are we? This particular talk I quite like. If you've not heard of Scott Vlashin, he's basically the go-to guy for F#. I'll post a link to his site, F# for Fun and Profit. It's pretty much where everybody learns. This is a talk he did, and this is just a thing that he explains. Functional programming really is all about the functions. Any of these kind of things you would handle separately. You just really think about them when you're in functional programming. So if you think about single responsibility, when you really distill that right down to its essence, if a class can only really do one thing, it's just a function. When you take it to an extreme, dependency inversion, again, we can just do that with functions that we did there. Interface segregation, if you segregate them far enough, you have an interface with one thing on it, that's a function. It goes on. So when we get into functional land, life just gets a bit simpler. So let's see. Let's talk about this add function a bit more then. So let's get rid of this. So you may have noticed that this is the types are inferred. This is what's it called, Hindley-Milner type system. It's ancient, from the 70s or 80s, how they do this. But it tends to scare people when you don't specify things directly. It feels a bit Python-y, especially because F# is also a white space-based language. Like it'll get annoyed if you do things with the wrong indentation and things. But it just works out very nicely. We can put as little or as much typing in as you want. I think it was only a couple of years ago that type annotations in Python have really taken off. But so if we call this with two integers. So in fact, we'll call this right here. We can do this in our REPL. Another common thing in functional languages, actually no exception, is having a REPL. We can just execute the code as we go. And in testing, so we tend to have a lot of pure functions. So we'll get into that in a bit. So we added these together, and it inferred this to take integers. Even before we called it, it inferred it to take integers because it's just the simplest thing it can take. If we were to give it two floats, it's changed its mind. Now it thinks it's a float. But what if we try to give it integers now? It dies. What are the yellow squigglies, by the way? It's expecting us to do something with this. Everything in F# is an expression, so it wants us to ignore it if we're not going to use it for something. So yeah, what do we do about this? So it is sort of, it can handle inferring generics. This sort of thing, we can just inline it, and we get these little careted types, which means it just works it out at the latest possible time. It works out when it needs to, and not when we define it. And yeah, just the simplicity of that, not having to define generics, not having to define what we need. But we can see here, it's worked out that this will take anything which has a plus on it. You know, you might be familiar with that sort of thing in Rust, if you've used any of that, where you can specify not just the types, but what the types are capable of. We can do this manually as well. It gets a bit chaotic if we want to do that manually, but we can specify types for individual things here. We can say it's an A, we can put int. We can say it's an A when a blah, 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 static manual. That's very rarely ever needed. I wouldn't bother with that kind of thing unless we're getting into hardcore library design or anything. It's not a concern. Largely, the way I like to go about it is writing with letting it infer types as long as it can until something goes wrong, and for documentation purposes, put in types where I need them. That's a pretty trivial example for it. But if we were to put into types for all of this, we'd say the one I want it to be an int right now. I want it to be an int, and it returns an int. So it doesn't look too dissimilar to like Go or even Python with type annotations. In fact, I think I don't really use Python. I'm pretty sure that's very similar syntax to Python's type annotations. Okay, so what about this bean? What if we wanted to say this function is only for adding beans together? Takes bean, returns beans. We can still actually call it with an int, which, you know, I personally like type aliases for expressing your intention. Sometimes in C# I find that difficult to get your intention across, and being able to alias things like this is just a very simple way of saying what, for example, what if it were user ID instead of beans? You know, it's really gets the idea across much better. But even though it is an int, we can just call it this. We can deal with that. We can make it so that you have to be very intentional about your well, your beans, essentially. So how do we do that? We specify that this is a single case discriminated union. We don't even need that. Bean event, which means that now if we want to pass something in, we have to wrap it in a bean. Yeah, we haven't specified what a bean can do yet, but that's going to be, I'll get to that in a second. So again, this, in just one little line here of at least in an int, wrapping it in a discriminated union. We'll get into what discriminated union is later, if you're not familiar. We've created this function that we've made it very clear without any other form of documentation what this does and what we want it to be able to do. I can't accidentally pass an integer to it. Again, bean isn't super useful. For a user ID, that would make a lot more sense. Yeah, because the user ID is not something we can add things together with. We wouldn't do it with an add function. But yeah, it wouldn't be, we wouldn't want to be passing around raw numbers for user IDs, for example. So expressing that through the type system is really where F# I feel shines. And Scott Blushon has an entire book on expressing things through the type system, domain modeling, many talks on it. It's one of my favorite parts about it. So at this point, yeah, so what's a discriminated union? It's basically an enum, but a more powerful one. So we can specify, for example, fruit of banana, apple. That's pretty standard enum things. We'll have a lot of that in C# or anywhere really. But the major benefit of a lot of functional languages, and F# included, is that we can pass data along with that. We can say that banana takes a number with it. We can take that, we can say that the apple takes a string with it. It's like the name of the apple type comes along with it. We'll get into uses of that in a bit. Just wanted to pad out what this actually is doing, because it is kind of confusing. What's a single case discriminated union? What's the use of that? This is pretty much the only use. Yeah, it's like having an enum of one, but where you actually have to treat it as a real one. So we can, in fact, unwrap that as it comes in here. And now it's an int. Why we got squiggly there? I think it's just delayed. It's lost its mind a bit. But yeah, now we have these unwrapped beans and our ints, because it's destructured. Essentially, C# has destructuring, but we have a lot more uses for it here. All right, let's get back to type providers then. So we've got to look at a tiny look into the type system, which I hope is whetting your appetite a bit. I really love expressing as much as I can through the type system. Right. So what happens if we were to have some mixed things? We've got an array in here. We'll just putting the JSON right in there. So this is just a sort of example JSON. We can, before we did the get sample to get the exact thing that was passed in, we can also just pass a different example of it. So we'll do that. The triple quotes, by the way, is like a verbatim string from C#. Nothing to worry about there. So we can say 4.5, slab, whatever we want. And if we pass that into the REPL, yeah, works. Gives us our type that's on it. So it's worked out in this particular instance that we have numbers and we have strings. It's given it to us as an array above. So let's do something with it to demonstrate some other parts of the language here. Let's pass that again with the ignore. Pass that to sum. So a sequence in F# is just an IEnumerable. I believe it's actually just a type alias for IEnumerables somewhere in the back, in the guts. And that shows us that we have access to basically everything from C#. When you go into F#, you're not learning a whole new world. The whole .NET ecosystem, everything is available to you. Some of it might look a bit different with the core things like IEnumerables, but it's all going to be there. So it's a lot easier to pick up than you might think. So we're just passing this number, this array of numbers, to sum, returns the sum of the elements. So why did I use this? We can just call sum, pass numbers to it. Oh, there, because we don't care about ignore, just want to get rid of the squigglies. We can just do this. That is calling the function. We don't need parentheses or anything. You might be familiar with that if you've used Scala. For single parameter functions, it lets you do this. So why do this? This is a pipe. I've seen a pipe in, if you use Clojure or anything like that, they use pipes as well, but just nowhere near as much as it tends to get used here. What does pipe actually do? Let's see if it'll give us the actual, no, it won't give us the code for it. All it does is pass the thing on the left to the thing on the right. It doesn't seem very useful until you think about using multiple of them at the same time. So if we were to, for instance, if we wanted to filter these numbers, create an anonymous function, lambda as you might know in C#. They look like this in F#. There's a lot of analogs. We'll say we only want the 7s, or we want anything that's more than 2. So if we put a 1 in there, only sum those. Also summed the 5 to 5. So what this essentially does is it gives us pipelines. It gives us chains of functionality, something that you might use, you build into your library like a builder pattern in C#, but it's this simple built in right there. If you wanted to do this in C#, it would look like, it would look ugly. We'd do it like, Jesus Christy. You'd do that, and then you'd have to, as a result of that, to another function. Just do the ignore again, just get rid of the squigglies, and you end up with code that looks like that. And you can make it look a bit better with some things like this, but it's just generally harder to see. It's ugly, and it's harder to work out what's going on. Here we are simply passing our data through a pipeline. And for example, I did Advent of Code this year, that kind of any sort of data manipulation. It's so nice when you can just pass things through, when you don't have to make a goddamn mess of what's happening. F# is quite popular in data sciences, probably the second most, well, maybe third most. You've got R and that kind of thing, and you've got Python with Anaconda and it's called NumPy and all that. And then F# does actually have a pretty well supported data science library and end ecosystem. So if you're into that sort of thing, we'd definitely look into F# for that sort of thing. So let me just, yeah, so here's one of my Advent of Code day 2 from last year, just piping things through. I want to, one of the password tests, we won't go into all the craziness that's going on here, but you can see that this is pretty similar to what we've just looked at. So if we want a count of whatever's happening in the password sequence, count by something, filter it, try and get the head, then map something to something else. If we failed, go with the default value of this. It speaks. It tells us exactly what it's doing. We don't need a whole lot of documentation. It's succinct. Most languages, I find, when you go for succinctness, you lose clarity. You get those rock style programmers who love doing what anyone else would do in 1,000 lines in 10 lines, and it's chaos. You don't know what you're looking at. You have to unpack it mentally. In F#, not so much. We have these nice pipes. So just to tack on to pipes, because we're talking about composition here really, is we can also just create new functions by composing old functions as a sort of a related doodad. Can't do with those two because they don't take the same things. But for example, if we go back to our take a multiplication as well. And then, so we could say take number 2, we'll pipe that to adding 5 to it, and we'll pipe that, the result of that to multiplying by 2. That works. That's a thing. We can also, if we're going to be using this a lot, reusing, we can create a new function, something silly, and pipe things together. So we would do this by perhaps creating, let's say, add 5, as we did earlier, where we used partial application to create a new function which expects just the second parameter. And we could do the same with 2, and then we can pipe these together in a reusable fashion. So because this is a function that takes an int, returns an int. This is a function that takes an int, returns an int. So all we're doing is saying this returned int, pipe that into the parameter of this one, and it gives us this add more function. Multiply by add 5, multiplied by 2. Yeah, add 5 multiplied by 2. 6 times 2, 12. And it's just sort of the heart of this sort of thing is composition, and that will probably keep coming up. So let's get into a nice chunky problem. You may have heard of the expression problem if you're not familiar with functional languages, and just want to do the simple explanation of what that is, because again, this is something you can go into academic levels about, but at just the human level is what's really important. So what is expression? The expression problem. It's a type of problem which is easier in functional languages and harder in OOP languages, or if you do it a different way, it's easier in OOP and harder in FP. But you can never really have both. So let's come up with an example. I'm going to create an interface because F# is not purely functional. So you can write just like C# if you really want to. And it's not just supported, it's expected. This is how a lot of people write. And I tend to stick to the FP side of things. I don't use classes a lot. I often forget the syntax, so I'm just copying off myself for this part. But yeah, so that's just what interface looks like. It's pretty standard. So here's a class definition. We're going to implement this interface. And all right, so super simple, pretty standard. Any first, my first C# book will have this sort of thing in it. This is what the class looks like under F#. I mean, you can probably read this as a C# dev. You could read this, you can interpret it, you can do what you want with it. One difference here is that interfaces are very explicit in F#. You have to specify that I am implementing this from this interface. You can't just, just automatically override things. Everything's a lot more explicit with F#. So let's create another one. So if we had a oops. And yeah. So this is your average couple of implementations of a pretty standard class hierarchy sort of thing. Let's make one just to So to demonstrate the explicitness there as well, you can't pass around, there's no sort of type coercion or conversions for types. If you want this to be a double, you've got to call it a double. If you had it somewhere as an integer, in order to pass it in there, you would have to explicitly convert it to what am I doing? Where am I? Yeah. And so as we can see on this rect, we don't have that function. It's because, again, explicitness, just to really show your intent. Again, a lot of this is about intent. We have to treat it like the shape. We have to say we want to use the shape interface before we can get to the area. This is a safe casting operator. Right, so what this shows us is that when we want to add an extra kind of shape with classes, we just tack that on. It's no problem. We just create another rectangle. If we wanted to add some new behavior, for instance, on a width function, suddenly it breaks our classes. We have to go through every class we have and manually add on a new thing, or we have we can create defaults in the interface. We have that in C#8, I think, brought that in. It will make it compile, but it won't give us a functionality. It won't really help us. So OOP gives us easy variance and not easy behavior. If we did the same thing in an idiomatic F# functional kind of way, we do this with a discriminated union, like we were talking about earlier. So call it P, shall we? We could use this thing can be one of double. So the asterisk is for a tuple, which came in proper tuples came in C#7, I think. Not those old school tuples with the type, what is it, value A, value B, type A, type B, whatever it is. So if we're doing this idiomatically through F#, we'd create ourselves a little module, which gets, if you look at this from C# or in a inspector, you find that it compiles down to a static class. So there's nothing crazy happening there. And we can create ourselves a function, say, give me the area of this shape. And what we would do is we would match on that shape's type. So C#9 brought in pattern matching, but it works quite similarly, but it's not as extensible. We'll look into extension in a second. So as to why would a C# developer want to do this, it's all about the extension. We'll get to that. So we would just do our same thing here. Offer a rectangle. Oops. We destructure our tuple there to get the actual contents out, and we do that. So now the idiomatic F# way, if I want to add more functionality, all I do is I come in here and I say, make a function in this module. I can make this anywhere. Find the width, and I'll do the same thing again. Check width, blah, blah. Whatever we're doing. And we will find that, oh, why doesn't it like that? Yeah, it's haha. We find that we get this warning. It's not an error, it's a warning about incomplete pattern matching. You should always, it will help you to always have meet every possible criteria, everything that could possibly be matched here. It will help you to do it. This gives us a lot of safety, a lot of, the compiler can tell us when anything's going to go wrong. F# is kind of like, it's more towards, like one of the selling points of Rust is if it compiles, it'll run. Yeah, you're never going to break it because it will force you to write code in a way that works when it runs. F# doesn't go quite that far. It doesn't have a borrow checker or anything like that, but it's sort of the safe middle point that I really like. That it will tell you, it will make you write code in such a way that is nice and safe, as long as you don't start bringing nulls in. Null does exist in F#, but it's just not used. It's idiomatically not there. It only exists for interop with C#. You will never see it in any real code. At least you certainly shouldn't. So again, with that, so we can see from this that adding behavior is super easy, but we want to add a new type, new variant.
Lee, could I just ask a question?
Yes.
The last section, line 32. I mean, F#'s really, it's very easy to read, but I'm struggling from line 32. Can you just describe to me what exactly that's doing?
The pattern matching?
Well, start from let and work forwards. Yeah.
Okay. So let is the binding. We don't use var or anything because it's not variable. Everything's always, it starts immutable in F#. So width is the name of our of what we are binding. Shape is the first parameter, just like the functions we created earlier.
Okay, yeah.
With the add, and to that we're assigning the result of a match statement. So everything's an expression. Everything results in something. Even things like an if. You know, in Python you have if, what are they called? I can't remember what they're called, but ifs kind of work as expressions. If true, then 1 else 0, that sort of thing. If actually returns something, whereas in C#, if is just a block. It's from its C heritage. It's just a control flow block. So we can say
that function matches shape only if it's got a circle of.
Yeah. So this is a binding. So it will, if it's a circle, which we have specified, or we specified carries along with it the data of this radius. then this is that radius. It binds to that radius itself. And in rectangle, if I didn't put these parentheses in here, I could just put, you know, data. That data is, where are we? It's not a double.
Okay, so the pipe is basically acting like function overloading here.
Yeah, so you can sort of see it that way, yeah. But
Yeah, if I pass in a circle, it does this function. If I pass in a rectangle, it does the other function. Yeah,
but it's more of a case. C#9 has this with its own pattern matching. It's on type. It's sort of the inverse of declaring it, saying if we get shape. So let's look into some other pattern matches to describe this. Actually, this could be helpful. So we can do other kinds of matches, like what's a good one? So we can match on a list. So let's take a look at list matching. I'll show you a slightly different syntax as well, just to annoy you really, because I don't like this this syntax, but I'll just show you because it exists. We can just declare this match. Instead of match something with, we can just declare this as a function which will match on its first parameter. So this takes a list of something and returns a string, is what it's worked out. Personally, I'm really not a fan of that. So let's just call this a list match, a list with the return of the match tag. So what we're passing in here is a list of something. It doesn't know what it is yet. And our match statement can bind the contents of that list in various ways that lets us deal with it. So we can, it's just sort of like destructuring. If you've seen destructuring in C# when you take a tuple and get the contents of it, or in TypeScript, TypeScript uses it all the time, where you can specify a type in a function in a function call, so that the actual guts of that type are available without having to dot into it, essentially. So now we've, so you see there so undo that. There it didn't know what it was. It was just an A type. Single. Now it knows that we've passed in a list of strings, because on the empty case, I returned a string of my own, and for the content, I've returned the content, so it must be a string. For them to return the same type, it must be a string. So it's pretty, the type system's quite intelligent. So this, let's give it another example to show you. So we can do it like such, which will get the first two parts of this of the list out and provide it to us here. But the most common kind of thing you will see is this, where it gives us the first element and then the rest of it in a list itself, string list. And functional programmers tend to do this so that they can make recursive functions. You will do something with the first one, and then you'll pass the tail back into the function. I'm not going to get into recursion because that's again a bit more of the academic side of functional programming, which we just don't need. We can write sensible functional programming without trying to be a 80s elite hacker sort of chap. But this just demonstrates our the binding of this. I'll give you another example. Yes. So because this is just, they're just union values or enum values. If you think it's easier to think of it as just enum with data, we can also do this with options. If you're familiar with options, if you've used them and you've used them in Rust, it makes quite a lot of use of it. Or most functional languages, really. You can use them in C#. I have used them. There are good libraries for it, but it's just not idiomatic. What an option is instead of null, we say they may or may not be this thing. So, for instance, or say maybe, yeah, in Haskell they're known as maybe types, I'm pretty sure. If that's more familiar, we could say this is sum of screw that, yeah. So this is an int option. So there could be an int here, or there could not. We don't know. I mean, we do know because we just created some. If we do the opposite side of that, we can do none. It's still an option. It doesn't know what it is now because we didn't give it a specific type, but we can match on match up with, it's either sum of something, in which case let's do an something plus 1. It worked out as an integer because I added 1 to it, or it's nothing, in which case we might want to raise an exception. You know, fail with is sort of the built-in throw an exception dealio. So it's really just binding to the content of what we're passing in. If it's a list, it does work differently for the different types. If it's a list, you have this sort of syntax. If it's a discriminated union, we have this sort. You can also do it based on type. If opt is an int, we can, is that the right syntax? I got that. Use demo type. Yeah, it doesn't know what we're dealing with at this point. Yeah. Yeah, so we can do it just like in C#, so we can do it based on type, but this seems like a good time to go into what I was mentioning earlier about extension of match statements, because they are quite a bit more powerful than C#. From what I've read, C# are going to be just adding other ways of matching. They will just increase things like the sequence. I think they're going to be adding this one and some other ones that F# doesn't have. And that's good for adding more features, but when it comes to F#, we can do whatever we want by creating what's known as an active pattern. So a good example. That little syntax there. We can say just basically a function which will return one of these options based on what's happening. And so from that, we can match our input with what we just defined there. Is it even? Then we'll print it's even. Is it odd? So we can put any sort of functionality into this match, and we can even pass along some data with it if we really wanted. You can get data back with it. I mean, I think that's the right one because we don't want to be using these. So let me show you a more useful example of an active pattern. Just copy and paste in this one I have lying around. Pass it a string. This, when we use this syntax, it just means either it will or it will not be what we said it was. So if we use this option thing to explain that, either it is something and we give it that thing, or it is not. So we never have to deal with nulls, and the match makes us deal with both options. So we'll never, this cannot crash at runtime. So we can make another one just to save some typing time. Make another one with for bool, and then we can match this. Oops. With, if it's an int, we can do whatever we want with the int. Let's do nothing for now. If it's a bool, just only a bool. So match is very powerful and idiomatic part of F#, which C# bringing that in is sort of heralded a new era of C# with this semi-functional, but it's still not as powerful as you will get in F# with much more succinct language as well. So looking at the time, getting pretty close to at least the hour we started past, was it? So let's switch gears a bit, get out of this dry, just writing things and blathering about stuff. And I'm going to show you the domain model of something I've been working on just for funsies. Just sort of modeling Carcassonne, you know, the board game, if you're familiar with the board game. Just writing a library that will allow you to run through the very simple base game of Carcassonne, no dynamic rules or anything, no expansions. I've got CLI slapped onto it, but it's also going to make an API. So I just wanted to show you how nice it is when you have your entire domain just right here. We can just talk through this and we can understand it. Even to just a non-F# dev, you can easily see what's going on here. You could show this to a business representative and talk through exactly what you are doing. So type point a record with an X and Y, both ints. F#9 now has records. It's basically a class with structural equality and significantly simpler semantics. So we just don't need to have 5 lines of whatever to get that done. So we have a point with an X and a Y in it. We have rotations. If you're not familiar with Carcassonne, by the way, all you need to know is that it's a game where you have board and you put tiles down, you can rotate the tiles and you can claim them. That's basically all you need to know. So we have a rotation, 0, 90, 180, 270 for the 4 rotations. We have a player ID. This is our single case discriminated union familiar, which allows us to specify that function must take a player ID, and we don't just accidentally or even intentionally pass ints around. A tile within Carcassonne can have features on it at one of these locations. 3 along the side, that side, 3 on each side or the center. We specify our edges, northeast, southwest. This is an attribute, just like in C#, just has slightly different syntax. We put this here because we don't want the content, these enum values essentially, to be accessible on their own. We want to have to say edge dot. Otherwise, they would clash with these ones. No big deal there. So here we have another structure of a record where each feature has connections to other features, a set of sections. No, it's just right there in one single line. A feature is a set of sections which connect to each other, and it's by a player ID or it's not. Again, in C#, this can always be null. I mean, we do have non-nullable types in C# that's made that a bit easier, but you're still dealing with the concept of null. We want this within our domain and within our available usage. What we're going to do with it, we are explicitly telling the user of this type, this may or may not be a player ID. Cities are special cases. So we go with composition over inheritance. We put the feature data inside the city feature data and add that shield. The shield is just an extra flag on cities within this game. You don't need to know what it is. So a feature can be either a road, a city, or a monastery. Roads have feature data, cities have special city feature data, monasteries feature data. Just so clear and succinct. What's a tile? A tile is a list of features. Boom. What is a tile placement? It's a rotation and a tile. So what can you do with the tile before you put it down? You're going to rotate it some way, and it's going to be a specific tile. What's the board? It's a map of points and these tile placements. One line, we've described the fact, we've described the entire concept of our board. It's just there are points around it and there are tiles on it. Our tile stack, which is where we draw tiles from, like if you were drawing a card in a card game, it's just a list of tiles. Player color, just an enum, one of these options. What's a player? Conti code. No, Conti code alert. Ignore that. A player is a player ID, and it's how new equals are remaining. And the entire game state we can then wrap up in this. We've got a tile stack, we've got a board, and we've got a double-ended queue of players. That's it. Double-ended, so we can just super easy. In 65 lines, we've described the entire domain of Carcassonne, which, if you got a spec to design Carcassonne, to write everything you needed Carcassonne in your day job, I'm pretty sure you'd write significantly more than 65 lines to work out your domain, and it would be much harder to see or understand than this would be. Now you can see it's just all on one page. I find a massive boon to be able to bring your entire domain into your brain in pretty much one go. It's not spread across a billion files. Obviously in C#, there's nothing stopping you from putting them all in one file, but it would still be huge and it would be non-idiomatic. You'd get slapped by your teammates. Maybe when C# does become more functional, the idioms might change, idia might change. That would be nice to see. But right now, this is just glorious to my eye. What's the rest of this? We won't go into I'll go into these. These are just ways of accessing the contents, because everything is immutable in F#. That means every time you change something, if that was inside something, you have to change the thing it was inside. If that was inside something else, you have to change the thing that was inside. For example, if you want to change a feature, the feature on this tile has changed, but tiles are immutable, so you need a new tile. And tiles are on a board. If that tile was on this board, can't change the board, we need a new board with the new version of the tile, and so on. This just makes life easier. There's basically setters and getters from a functional point of view, so we won't go into that. All right, so before we wrap up, I'd just like to show you one more type provider. Didn't go into all the type providers I wanted to, but this is just probably my favorite type provider. Let's get rid of all of this gubbins. A Swagger provider. We'll just slap that in so we don't have to type it out, running low on time. Sure, we don't need that. So if you're familiar with Pesto, it's just sort of it's an example you can use for API calls for in whatever you're doing. Get rid of that. So we'll run through this line by line and show you what we get out of it. So we've got a string literal. It has to be a literal because it uses a compile time. It's just a quirk of the language there. So we go and get the Swagger file at compile time from this URL. We create a client. That's essentially 2 lines. This could just be in here as well. It's just a bit ugly. It could have been 1 line. And what we get out of that is a strongly typed repo essentially to that client, well, a client. And you've got the documentation. We've got delete purchase order by ID, delete pet, whatever the hell we want in there. We've got, it knows things it's expecting, username, string, and we can just call these. 2 lines of code. Shadow, what's that? No. We can just call these right up. It just went and got me a whole bunch of these pets that random people have put onto this public API. You can do this with your APIs. It may concern you that this is compile time. You don't have to do it with a URL. You can put the Swagger in your project. You can embed it as a resource, things like that. So it's not as scary as it looks. But this is just a kind of a game changer for clients. You don't need to generate anything. You don't need extra steps. You don't need anything bananas. In 2 lines of code, you have a client. We've got the types specified in there with constructors, categories, pet stores, photo URLs. It gives you everything you need. And there are many different kinds of type providers lying around. You can make your own type providers. There are SQL providers is a common one. There's basically any sort of format you could think of, JSON, YAML, that sort of thing. So yeah, type providers are my sort of hook to get people to think, man, that's cool. I wish I could write F#, because if you can do that in 2 lines, what can't you do? So yeah, we're running a long time. Are there any questions while we have a bit?
Any questions for Lee?
Yeah.
Yeah, I've got a question. If you took that type provider there, I know there's some interop with C# in F#. Is there sort of type interop as well, or is it? I mean, could you make use of that pet store type from a C# program?
I think you can, yes, because it's embedded in the assembly. I've not tried that because I don't do a lot of interop, but yeah, it actually, it generates that type and slaps it into the assembly for you. So I'm pretty sure that would be accessible from C#. So yeah, you can just have an F# project with your generated types in it and access everything else from C#.
Okay, and just on the same, while I've got the microphone, is there a sort of any kind of central repository, if you like, of type providers? Is there an obvious place where you can go to see what type providers people have written? Because I don't think writing them is that straightforward, is it?
It's not super straightforward. It's one of the more complex things you might do in F#. F# Data is a project which collects a bunch of these together. There are quite a few in there. JSON, all of these come from there. There's and we've got another one lying around here. There's an HTML provider as well that they create here. So if we just go to the Wikipedia page for Star Trek, it will go and extract what it can. You can find that there's some tables in there. We can start processing. This is great for scraping or just any little script you need to do while testing, automated testing, pretty great for too. Like we can just start processing this. Same for each television series, group it by the showrunner or the episode or the season, things like that. So yeah, check out F# Data. I'll put a link to that in when I dump a few links for you. That will be the closest thing to a central repository you'll find.
Okay, thank you.
I have a question, Lee. Let's say I want to get going on F#. I've been inspired by what you were saying today. What's the quickest way I can pick this up? What sort of resources would you point me to get going on this?
Yeah, that would be good old Scott Vlashen, how the hell you pronounce his name. F# for F# for fun and profit. Put that link down. He's been writing things for the better part of a decade, basically since F# came out, and his explanations of what you might think are difficult functional concepts are incredibly easy to wrap your brain around. He will explain what a monad is to you, and you'll wonder why anyone ever thought it was a complex thing. It's just not. The problem with that functional programming is they have a lot of complex names for simple things because it has a mathematical background, and Scott Vlashen will clear that up for you. Yeah, he's a one-man wrecking crew for education in F#.
Okay, if you could post a link on Meetup, that'd be appreciated.
Yeah, I should do that.
Great. Any more questions for Lee?
Yeah. Well, yeah, I mean, I skimmed a lot of topics there. So it is quite an information dump, but I hope it gave you enough of a clue as to why these are beneficial from a C# point of view. If there's anything where you were thinking specifically, yeah, but why do I care? Those are the kind of questions that I'd be interested in. I'll post it on the Meetup if there's a few later.
I could chip in there if that's right, and say like what. So I think you started talking about it right at the beginning, like before the talk. What the job market is like, because I mean, I get the impression this is a lot of fun to learn in your spare time, but there's not actually really any jobs.
Yeah, the job situation is not great. You'll find some remotely. I believe that UK is not actually too bad on in the global scale in terms of percentage of jobs. UK has more than most, but yeah, there are not a lot of them. I know a few people who've worked with it, but my goal here is to get the word out and to increase that number. The more people using it, the more jobs there will be. I know that Jet.com use it, which is one of the bigger companies that advertise their usage, which they're sort of an Amazon alternative. Probably the biggest usage of this, and shown that it does work at an enterprise scale. But yeah, I have seen it in some.
I've actually met some professional web developers who write solely in F#, and they run an e-commerce system on it. So you can do everything in F#. You can do in C#, and
yeah, my blogs are in F#.
They talk reverently about the days they went F# and left C# behind. And
it's a good day. Yeah, I even do the front end with F#. There's an F# to JavaScript transpiler called Fable that I would heartily recommend as well. it's so nice to not have to use web technologies to get get web results.
I think
And you also mentioned scripting.
Mhm.
Is that sort of not terribly painful to do with? I mean, I guess the type inference is so good that you don't need to. It's quite straightforward to do scripting in F#.
Yeah, I used to generally use it for things like I work. I needed TypeScript to go through every Git repo I had and do a pull, things like that. Whereas in Bash, I just constantly forget all the function syntax, that kind of things. Yeah, in F#, you get yourself a Git library, or even just call process, and you can create a pipeline like this in a few lines. Create a pipeline to go into this folder, make this call, go out, go around. Simple things. Whereas in C# you have the CSX. It's just not that easy to develop through it because you don't have your REPL. And thematically, again, in F#, most functions will be pure, or at least attempt to be pure. And it makes it a lot easier to work from a REPL. You put some inputs in, you get some inputs out. And then you compose them, build them up. So you'll always be able to test every level of it. You don't need to write specifically testable code like you do in C# as well. So it just brings the simplicity level up quite a bit. Yeah, I don't have an example of that lying around right now, but yeah, the first time I did this talk, I did it entirely in a script file rather than within a project with any sort of project overhead with it. So yeah, anything you can do elsewhere, you can do in a script, and then you can just set up to double click it and it runs.
That might lead nicely on to Robert Harker's question. The examples given seem to have a lot of code in one file. How does this fit with code separation and clean architecture? Yeah,
so yeah, the F# way is to tend to, well, a common way of handling it is having your domain just slapped down. You have all your types up front. And yeah, at first it took me a bit to think, well, that just seems messy. Look, none of these have anything to do with each other. Player color doesn't have anything to do with your tile stack. But you're not approaching this from a clean architecture sort of mindset. You're approaching it from a developer trying to write some things and keep this in my brain point of view. It's a more human aspect. So yeah, it's an idiomatic issue that you don't need to separate things quite so much. You just have your domain and you have some functions that operate on some things. You would split out your modules. So for instance, I have my point up here, and then I have a module for point, which has all my point-based functions in it. I have a module for player, that's my player, not like in there. Type, for instance, tile, for instance, get me the sections for this edge. We would split that all out in modules. But this is open for interpretation. There's a page on Scott Blashen's site where he goes through different ways you can do this and how they impact interop. Because you might want to do it from a clean architecture point of view. You can just absolutely do that in exactly the same way. And then interop with C# will be a lot better. But if you're not worried about interop, you would just have a domain and your functions. And then you would use them from another module. For example, like the game function we have here just imports not a lot. So we just have our model and we just create submodules. Yeah, these questions just don't really come up. I had the same issues when I first started, and it just never came up. It's clean without needing to put so much thought and effort into it. If that helps at all.
Kevin Smith has asked the question, do you have examples of what tests look like in F#?
I have some unit tests of my own. This is just a particular, what library am I using here? FSCheck. So this will look very similar. You can use NUnit, you can use everything. Most people, I think, just use NUnit. But here's an example of, okay, we've got list of tests, it's got a name. And the list is literally just an array. of tests. So there's no funky reflection or anything going on there. You can see exactly what's going to happen. It will take this list, it will run through a test. This test is a computation expression. I did not go into computation expressions. That's another of the more complex areas, but you don't need to use them anywhere, so we don't need to worry about that. Something that you get in tests, in more functional tests that you don't often see in OOP tests, is things to do with property-based testing. I don't know why you don't see that much in OOP. I think it's just something that comes with the territory. But things like, for every non-integer, we can create a type which will generate us non-positive integers, and then for every non-positive integer, run this test. So yeah, the tests don't look too different. It may look dense at this point, but when you actually start reading it and you know your domain, it's not really particularly dense at all. And yeah, this is just one of many libraries. So yeah, you don't need to worry about it feeling too different for tests either. As I say, most people just use NUnit. Yeah, I didn't go into operators or go into the monad side of things much, but yeah, another thing that scares people is operators. It looks like there's a lot of scary things going on here. That's a very standard operator. It's a bind operator. Once you learn like 2, maybe 3 operators, you're fine. Cool. Any other questions?
No more questions from the chat.
Cool. All right then. So yeah.
Well, if you can put those links in Meetup, it'd be much appreciated. Thanks everyone for coming. Thanks very much, Lee, for a fascinating talk.
Mm-hmm.
So I need to have a second and third look at F# before I wrap my head around it. But it looks really powerful.
Yeah. Yeah, I hope I didn't make the situation worse by skimming so many topics, but I hope for each individual topic I mentioned, you can see that there is simplicity and power available to you that you're probably not going to get in C#. Cool. Where the hell's that one? Yeah, all right, so I'll post those links directly after this.
Great.
And I'll read through the chat, see if there's anything else I can talk about in the forum. Cool.
All right. Good evening, and we'll see you all at the next talk, whatever that might be. We haven't arranged anything yet.
All right. Thank you all.
Take care. All right.